All right, first thing to realize in the preliminaries before we get down to the analytics is the similarities and differences with the product markets. Let's look at the differences with the product markets. And for that, we refer to the circular flow from chapter 4. And notice that the role of firms and households are reversed in the labor markets from the product markets. Remember the circular flow diagram? In this flow on the upper part of the schematic, firms are supplying goods and services, so this is the supply, and their households are demanding goods and services, so they're the buyers, the firms are the sellers or the suppliers, and the flow of goods and services works along the red line, the flow of income. When households are demanding goods and services, they're paying or spending money which flows as revenues to firms. This upper part is the product market. When you look at factor markets on the lower part of the schematic, you'll see that the flow of services and income is reversed. Now the firms are the buyers or the demanders of factors of production. So we're going to be representing the demand curve as the demand by businesses for labor services, and households are supplying labor services and receiving the income, and businesses are paying wages. Here are the wages, and in these markets you have the supply and demand for factors of production. Now we're going to focus on labor, but if we had to extend the analysis, households, this diagram and the analysis assumes that households also own all the land and capital. Our focus would be on labor. Okay? So households supply labor services, businesses demand labor services. So what we're trying to do next in this chapter is analyze the forces of supply and demand as they apply to the labor market. Okay. Now, other similarities and differences to note when we're looking at labor markets is that to emphasize that labor is not a commodity like that you're buying for consumption that individual consumers get utility. It's the labor services that firms hire temporarily. They're hiring the services. So you're not really buying a product, you're not buying labor. Businesses hire labor, and the wage rate in a sense is the rental from hiring labor services over a period of time. People are not commodities, they're not purchased and sold. And the demand for labor services is a derived demand from the firm's decision to supply a commodity in the labor market, in the product market. So businesses make decisions to supply goods and services, to supply and produce goods and services, they have to hire factors of production. Those two decisions are interrelated, but it's the derived demand for labor is derived from, or the demand for labor services or any factor by the firm is derived from a demand for the firm's production of goods and services. Other differences that we'll note between the product and labor markets is the product markets for some commodities, especially in perfectly competitive industries, have a very much larger predisposition to supply commodities as prices increase. So supply elasticities can be fairly large in certain markets for certain commodities, depending upon the different factors that determine the magnitude of the elasticity. But especially in perfectly competitive markets, we find that supply elasticities tend to be rather large. In the case of labor markets, it's the ability for individuals to increase their supply of labor is limited by the simple fact that there's only 24 hours in a day. Time is limited. So that makes labor supply tend to be relatively inelastic with respect to different variables, especially the wage rate. Another difference, in product markets, you tend to have equilibrium where there's no significant excess supply. In equilibrium, the demand is equal to supply at that price for products. In the labor markets, there's always some excess supply, meaning there's always some unemployment. Whether it's frictional, technological, or structural, or cyclical, even when an economy and the labor markets are at full employment, there's always some unemployment. At full employment, maybe 5% or 6%, or maybe a little less, but that still means 4% of the labor force is unemployed. finally, what we find is, unlike product markets, where products are relatively similar, you tend to see very small differences in prices. Whereas in the labor market, there are persistent wage differentials that are difficult to explain. Now, when we analyze the labor market, economists generally take two approaches. The microeconomic approach, which is the approach we're going to take, and that's called the neoclassical marginal productivity theory of wages. Essentially, that's the theory that says that wages are determined by the supply and demand for labor. The demand for labor reflects the marginal productivity of workers. That's why it's called the marginal productivity theory, the neoclassical theory. So we're going to look at the production function and look at marginal product of labor as being very important in determining the demand for labor. There's another approach that economists take at the aggregate level. That's the more macroeconomic approach that looks at the market as an overall one labor market. Obviously, that may be counterintuitive because, in fact, the actual labor markets at the micro level, there are lots of different labor markets because different types of workers, different professions, different wages, there's executives, there's janitors. So you can look at markets separately, all for those professions or for different there's a dual market theory. The macroeconomic approach looks at the labor market as one market. So there's two different approaches. Our approach will be to look at, to take the neoclassical microeconomic approach. And that essentially, as you can see in this diagram here, and I'm going to ask, let's see, hopefully this will come out. Okay. This looks at the neoclassical approach, the microeconomic approach. Essentially, let me reduce this a little bit to get the entire diagram in. Looks at the labor market. This is the picture of a typical one labor market. If all workers were the same and all firms were the same, the equilibrium in the labor market is the intersection of a demand for labor, which is a downward sloping curve, like all demand curves are downward sloping, reflecting the fact that the lower our wages, the greater is the quantity of labor demanded by business firms. We'll see later that the demand for labor by an individual firm is called the value of the marginal product. On the supply side, the supply curve reflects the inclination of individuals to supply labor versus take leisure or take time off. There's the labor-leisure choice on how to determine the supply curve. So the supply curve reflects the decisions of individuals to want to work rather than take time off and take leisure. That supply curve can be generally upward sloping over certain ranges, especially for low wages. The higher the wage rate, the more I want to work, the more workers want to supply. But as wages get higher and higher, what we find is that this curve may actually become inelastic and may actually bend backward. That's called a backward bending supply curve. The economists have found evidence that the curve bends at high wages. So this essentially is what we're after. Now, the next part of the lecture will look at deriving these two curves, the individual demand curve and the supply curve. And we're going to do that next. Okay. So, the labor market is governed by the laws of supply and demand, just like product markets. The labor demand is a derived demand for labor services. Remember, labor is an input into production of goods and services. And for this, understanding how the demand curve is derived, which is going to equal the value of the marginal product curve, remember that the firm is hiring factors at an equilibrium. The demand for labor comes from the business firm that is maximizing profits. In that problem, we have to go back to the theory of the firm in perfect competition. The firm is hiring labor, capital, land, and materials, and is producing a product based on hiring of those factors, and the goal of the firm is to find the profit maximizing level of output. And basically, then, the demand for labor by businesses is a result of the supply of goods and services in equilibrium. Restating that, what I just said, When the firm is finding the level of output at which it's maximizing its profits, in any market structure, we're going to start with perfect competition. Once that decision is determined and the firm finds the profit maximizing level of output, the production function relationship, where production is a function of labor, automatically determines the optimal level of labor hired. Those two decisions are intimately linked. So essentially, the firm's profit maximizing equilibrium for determining the profit maximizing level of Q predetermines the profit maximizing amount of labor hired. And for that, I'm going to draw some diagrams here. And hopefully Brian can help me. Ryan, with that these diagrams will be in focus and we can see what we're talking about. Let's go back. We said that to find the amount of labor, this is in the labor market, that the firm hires, okay, we'll call that N. We'll use N for the symbol of labor. Labor can be measured in terms of number of workers or hours or man hours, which involves both variables, okay? Now, here we're going to talk about the product markets, these two graphs here. All right, in the product market, remember, the entire market of supply and demand determines the price at which the perfectly competitive firm sells its output, right? This is the price which is given to the firm. The firm's decision is to find the level of Q. This is a review, by the way, okay? Which level of Q maximizes profits? And remember, that decision is determined by the intersection of the price given in the marketplace and the marginal cost curve. And the rule of thumb is Q that maximizes profits, or Q star, is that level of output where P equals MC. Price is equal to marginal cost. This decision determines the amount of labor the firm will hire at any wage rate. So let's go to the labor market and the wage facing the firm. Our problem now is to determine how much N the firm will hire corresponding to this P equals MC. Now let's go back to this equation and manipulate the variable somewhat, okay? Let's start here on this side, P equals MC. Remember, the firm is in the short run equilibrium now, not long run. In the short run, there's only one variable which varies, N, labor, the amount of labor the firm hires. The amount of capital is fixed, the amount of land is fixed. All other factors are fixed. So in the short run, capital costs and all other costs are fixed. Only labor costs vary. So the cost, the only marginal cost, all right, we'll see ends up being the only factor that determines changing costs are labor costs, since labor is the only factor that's varying. Let's go back and see what the definition of marginal cost is. Remember what marginal cost was. Marginal cost was the change in total cost divided by the change in output. Now, because it's a short run, the only thing determining the change in total cost is variable costs. So we can rewrite change in TC as the change in total variable cost. And by the way, this refers back to chapter 13 where we derive the cost functions. So if you want to go back to 13, this is where these equations are derived from. We discussed this. But now what we've done is we've translated marginal cost into this ratio. Now decompose what are variable costs. Variable costs are the costs associated with the variable input. What's the only variable input in this example? Labor. So the change in variable costs are the change in labor costs. What are labor costs? Wages times N, employment. So this translates to this. Now, another assumption that we make here is that the wage rate is fixed. Put a bar over it. If the wage rate is fixed, then the change in the numerator is the same thing as the wage rate. So the wage rate is not changing. The only thing changing is N, the level of employment. But in the denominator, we have a change in Q. Now, look what this expression is. The price in equilibrium, when we say the price is equal to marginal cost, it's the same thing as saying price, bringing this down to this side, is equal to the wage rate, this wage rate, times the change in N over change in Q. What is this ratio? The inverse of the marginal productivity of labor. The marginal product of labor. So, P equals MC is the same as P equals the wage rate times 1 over the marginal product of labor. Now, we manipulate this a little further by multiplied by the marginal product on both sides. You have P times the marginal product of labor is equal to the wage rate. This is the equilibrium condition. That's the same as this equilibrium condition. Let me repeat. When we say that a firm is maximizing its profits, it finds the level of Q star in this case, at which P equals MC. It's the same thing as finding the amount of labor that it needs to produce Q star. To find the amount of labor, the firm takes and looks at the wage rate and compares it to this, P times MPL. P times MPL is the marginal product valued at the market price. In other words, it's the value of the marginal product of labor, which equals the price of the output, Q, times the marginal product of labor. This is the demand for labor. So, this theory allows us to derive the demand for labor. Then to find where the firm hires, in this case, if this is the demand curve, the firm hires this amount of N, is the profit maximizing amount of labor hired N that corresponds to this from the production function. Another way of saying that is that this is the demand for labor is the firm's the value of the marginal product of labor. Meaning that whatever the wage rate is, the firm looks and goes across to the demand curve and says, what is the marginal product of the workers? And that's how many workers are hired. Let me put it another way. Let's say W bar is the wage rate that that firms face. This wage rate is determined in perfectly competitive labor markets where there's a lot of workers supplying labor and there's a lot of businesses. Okay? This wage rate is given to the firm in the labor market. Given this wage rate, or any wage rate, the firm looks at the wage rate and compares it to the worker's marginal product, the value of the marginal product. For example, let's say the firm is at this point, hiring N0. Goes up to the demand curve at N0, the value of the marginal product at 0 is greater than the wage rate, meaning workers and what they produce is generating more revenue to the company than what it costs them per unit of labor, per hour. So they keep hiring and they increase until equilibrium, the two are equal. Let's do an example. Let's do a couple of examples in the 20 minutes remaining. The first example will be from, again, the cost curves that I presented in chapter, this is an extension of this. This is the theory here, an application of this theory. Now, in this example, I'm going to have to erase some of this so everything comes out on the screen. But the first example is, again, from the cost curves that I developed and presented in chapter 13. For this, I'm going to have to shift to the document projector here. And remember, hopefully, I'm not sure if this will all come out, but I think you'll recognize, Ryan is going to try to get this legible for me. You'll recognize this output, hopefully this slide. And you remember that problem, I had 3 or 4 sheets where I had a hypothetical example of a firm. We were trying to derive the cost curve, the total cost, based on 3 plant sizes, 1,000 square feet, 2,000 square feet, and 3,000 square feet. The assumption were the fixed cost, the capital, the plant, the office, was costing 10 cents per square foot. The wage rate, this is not where the labor market comes in, is $10 per hour. And this is the production function for firms with 1,000 square feet. Let me see if I can get the total data up there on the board. Okay, remember that production function. Okay, I'm going to put just this part enough because we're dealing with the production function. All right, the production function was a relationship between the amount of labor, this is labor in hours, so this is 7 hours of labor, 12 hours, and this is how much those labor hours produce for the firm. This is the production function. All right, and we had, our problem was to derive the cost curve, and first thing we did is calculate the marginal product of all these workers. Now we're going to extend this analysis and assume that this perfectly competitive firm is selling whatever Q is being produced, the optimal amount, at $100 per unit. So the idea is we're going to try to find what is the profit maximizing level of Q, which one here maximizes profits when the price is $100 and when labor costs are $10 per hour. All right, now let's go back, and what you will find is that I erased it here, that this declining value of marginal product curve is essentially part of the curve of marginal product that's declining multiplied by the price of the output. Let's put up a graph of the marginal product corresponding to this production function. Remember this graph? All right. This graph shows us the marginal product curve. The marginal product, remember, is the change in total product divided by the change in labor, this time measured in hours. And here's the value which is graphed along this curve. Notice when the curve reaches a peak and this starts declining, it looks very much like our demand for labor. And in fact it is. The demand for labor is the declining marginal product curve multiplied by the price of the output, which in our case is going to be $100 per unit. All right? So here is somewhere along this spectrum here, this variable on this axis, this dimension, is the optimal amount of labor hired. It turns out it's going to be 38, but that's determined by the optimal amount of Q that maximizes profits. For that, let's go back through the data when we calculated the cost curves. And we're going to focus only on that top table right up there. Hopefully it'll come out. If it doesn't come out clearly, remember to refer to the notes that I gave you for chapter 13, the handout. And what I want to do is, let me change the scale here so that you can see, or move the graph around a little bit so you can see all of it. Okay, that first table is the derivation of the cost curves corresponding to a firm which is 1,000, here you can't see it, but it's 1,000 square feet, the small scale of plant. Okay? Now, here's the marginal product here, which I just transcribed from the earlier page. Here's the amount of labor, this is your production function, the fixed cost, variable cost, total cost. Now here is the important variable of marginal cost, and that is used to determine the profit maximizing level Q star. Now, to find Q star, you need not just marginal cost, you need price and marginal cost. If the price is 100, we have to find the level of Q corresponding to a marginal cost of 100. And 100 is achieved at this point when output goes to 6. Now notice at 6, what is the corresponding amount of labor that maximizes profits? 38 hours of labor. So therefore, 38 is the amount of labor hired by the firm. Notice one more thing that I put here in this column, which I filled in, which is not in the original handout. I calculated the marginal product of labor to show you that at this optimal amount of labor hired, at 38 hours, you'll find the wage rate, which is $10 per hour. Remember we said the wage rate was $10 per hour? is going to be equal to the value of the marginal product. To do that, you have to calculate the value of the marginal product. How do you calculate it? The value of the marginal product here, VNPL, is equal to the price of the product times the marginal product of labor. The price of the product, we said, was $100. The marginal product is this. 100 times 0.143 is $14.30. What does that mean? That means for the first 7 hours hired by the firm, each hour generates $14.30, but it's costing the business $10. And it's paying, every hour is costing the same amount. That's the wage rate in the marketplace, $10 per hour. But labor each hour is bringing in $14.30. In other words, for this business, 7 hours doesn't maximize profits because labor is bringing in $4.30 more per hour than what it's costing them, than its cost. So a business wants to hire more labor. Take a look, if it produces another unit, the 2, it needs to use 5 more labor hours, to 12. 5 more labor hours, because of increasing productivity, the workers now, what they're bringing in is $20 per hour, but the firm is still paying only $10 per hour labor. So it pays to hire the additional 5 units of labor. Same thing for the next 4. They're bringing in $25 per hour compared to the cost. Okay, if I had to do that on the graph here, let's put this graph back up. This is $10 per hour wage rate given in the marketplace, and this is the value of the marginal product. At this point, when this is $25, it's not equilibrium. We know the equilibrium is at this point. This is the demand for labor, this is the wage rate. When the firm is hiring, and here we measure N, the amount of labor hours, 16 labor hours. Notice at 16, as I said before, each worker is bringing in $25 per hour, and it's costing the firm 10, so it pays to hire more workers. If you keep doing that and follow that logic continuously, the next 5 labor hours to 21 is still profitable. The next 5 to 28 is still profitable. When a firm increases from 28 to 38, it finds that at the margin, the value that each worker brings in, meaning the marginal product of 0.10 times the price of that output, $100, is exactly balanced with the cost per hour. And that's this point. At that point, it will stop hiring. It won't go and hire more workers, because to hire more workers beyond equilibrium, their wage rate, $10, is greater than the corresponding value of the marginal product. Hence, the equilibrium for this firm, for this example, is the maximum output is 6, corresponding level of labor, 38 hours. That's the example from chapter 6, applied to the labor market. Now, let's do one more example from the text. Okay? And let's start the analysis with these 2 broad diagrams of, this is the labor market on this side. In this case, this is an apple example. So you have the product market as the farmer's market that determines the supply and demand for apples, determines the price at which apples are sold in the market. All right? Once Q, the quantity of apples in the marketplace, determines the price, the individual wage rate for apple pickers depends on the market for apples. Here is the apple market, or the market for apple pickers, which determines the wage rate, okay, for apple pickers. Now, carry this labor market over to the individual farm. This wage rate now is given to the farmer, and his decision is to find the optimal amount of the number of apple pickers, which maximizes the profits. So you have to see, what is the individual farmer's demand for apple pickers? It depends on the value of their marginal product. At the intersection of that is what determines N star. Let's look at actual data for this example of the apple farming market and the market for apple pickers. Okay? All right, extending this analysis, again, in other words, repeating what I just said, the firm is a competitive firm in both markets. Both the apple market and the apple picker market are perfectly competitive. Remember what that means, because that's very important. That means at the product market, the apple farmer is a price taker. At the labor market, he pays the market wage, and the reason that's important, that it's competitive, that means that the farmer cannot influence the wage rate, because he's a small part of the total product market, and the amount of labor that he hires is a small part of the total labor market for apple pickers. Okay? So the decision is what's the quantity of apples picked, and what is the quantity of apple pickers that he's going to hire that maximizes profits. Now remember, both decisions on Q and the amount of labor N are a result of or reflect the production function relationship, which is a relationship between the quantity of inputs used to make an output and the quantity of that output of that good. Okay? The production function is, for this example, reflected in these data in the first two columns. Okay? Here's the quantity of labor measured not in hours like our earlier example, but numbers of workers from 0, 1, all the way through 5. These workers produce so many bushels of apples. This is the column, and so these two variables define the production function. Okay? From the production function, we calculate the marginal product of labor, which tells us for each additional worker how many additional bushels of apples each one produces. Okay? The value of the marginal product, here's the marginal product, then is the price of the apples times this marginal product. In this example, the price of the output, Q, is $10 per bushel. Right? At $10 per bushel, if the first worker produces 100 bushels, those 100 bushels can be sold for $1,000. That's the value of that worker. However, because the wage rate is fixed, the wage rate at this column here is constant, meaning that because of the competitive assumption, the apple farmer doesn't have to raise his wages paid, his salaries, the amount that he pays for labor, as he hires more workers, because the competitive assumption means there's so many workers competing with each other that wages are fixed at 500. So the first worker produces 100 bushels that can be sold for 1,000, but it costs the farmer 500. We may be at this point here. This is the wage rate. Here's the first worker. Okay? So his value is 1,000. It's costing 500. The value to him for the first worker is much greater than the cost. Does it pay to hire the first worker? Yes. Take a look at the second worker. The second worker produces 80 bushels. Does it pay to hire the second worker? Well, yes. 80 bushels means he's bringing in $800 in revenue. The cost is 500. The profit, 300. It helps to hire the second worker. You do that until it doesn't pay to hire the additional worker, and at what point does that happen? The fourth worker brings in 40 bushels. At $10, he's only bringing in $400. It's costing $500, so the firm doesn't hire the fourth worker. The optimal amount of workers hired stops at 3, where the value of the marginal product is still greater than and never less than the cost. So essentially, though, in this example, the equilibrium is not at the intersection point, but is at this point of 3 workers. So the VMP is the demand for labor curve. Okay? Why is this the demand for labor? If wage rates were $1,000, the firm would hire only 1 worker. Remember what a demand curve tells you. For a given price, in this case with the price of labor, what would be the quantity demanded of labor? If wages were 1,000, the firm would hire 1 worker. Wages were 800, the firm would hire 2 workers. That's a demand curve, and it's downward sloping because of the downward slope of the marginal product curve. All right, in the remaining time I have left, and we're not going to be able to analyze the supply curve, I will do that in the next lecture. I just want to discuss a problem in the textbook. This would be problem number 3, chapter 18, okay? So I am going to put the problem on the screen, the wording of the problem, problem 3, just to set it up, and in 5 minutes I have left, I'm going to solve or answer some of the questions, okay? So let's do that, and I'm not sure whether this will come out on the screen, whether it's going to be very legible. First, let me erase some of this. Anyway, if you can't read it, remember, I'm doing problem number 3. Remember that you also have the answers to this problem, okay? Here's problem number 3, which I'm going to project. That's basically the data for problem number 3, okay? Suppose that labor is the only input used by a perfectly competitive firm. The firm's production function is as follows. Days of labor, units of output corresponding to this amount of labor. The questions are, I'm going to read them because you won't be able to see them. Calculate the marginal product for each additional worker. Each additional output sells for $10. Calculate the value of marginal product of each worker. Compute the demand schedule showing the number of workers hired for all wages from 0 to 100. Graph the firm's demand curve and what happens to the demand curve when the price of the product rises from $10 to $12 per unit. Okay, now I'm going to put the answers up, which remember are on the website. Okay, here's the table with the answers, and I'm going to expand this, blow it up a little bit. All right, hopefully let me erase this. This comes out and you can read it. All right. These two columns basically duplicate the information from the text. All right, here we go. So the first question is calculate the marginal product for each additional worker. Marginal product is the change in total product divided by the change in labor. So 7 minus 0 divided by 1 minus 0 is the marginal product of the first day of labor, 7. Of the second day of labor, it's 13 minus 7 divided by 2 minus 1 is 6. Here's the marginal product. Now, the demand curve for these workers is the marginal product times the value of the output, whatever the firm is producing. Remember the assumption in part B. Each unit of output sells for $10. So it's a simple calculation. Value of marginal product is P times the marginal product of labor. Here's the marginal product. Multiply it times the price. What's the price? $10. So $10 times 7 equals 70. $10 times 6 equals 60. $10 times 6. Notice the productivity. This is rather unusual, where the productivity of these 3 labor units stays the same. Normally it's always decreasing, okay? On and on. Always $10, $10. Here's the value of marginal product. This is the firm's demand for labor. Now what I've done here in this other column is calculated, the next part of the question says what happens when the price of the product rises from $10 to $12? Well, now each one of these is multiplied by 12. So 12 times this is 84. 12 times 6 is 72. Now, this is not a 1. And so this is now the new demand for labor curve. So if we had to graph it, right, this is what the graph would look like, or the 2 graphs, okay, from these data in the 30 seconds I have left. Those 2 marginal product value or value of marginal product curves, here's the initial curve, tell you that if the wage rate was, whatever the wage rate is on this axis, this curve tells you how many quantities of labor units they would hire. If wages were 70, the firm goes to the curve, goes down to this axis, would hire 1 day of labor would be the profit maximizing level of labor hired. Okay? That's why it's a demand curve. This is the original value of marginal product when the price was $10. If the price goes up to $12, the curve shifts to the right. That's like saying, in fact it's not like saying, it is saying the demand for labor has increased because the price of the output has gone up. Meaning, the same productivity of labor sells for a higher price, the firm is actually making a higher profit, and every labor hired, every unit of labor is now more valuable because the price of what it's producing is selling at a higher price. So essentially that's saying if a firm can sell its output at a higher price, the demand for labor goes up and shifts to the right. That's what's happened. That's how you show the shift. Okay, that pretty much ends, remember to do this problem. Problem number 3, page 394. That ends this part of the lecture. We don't have time to do supply. We'll do the supply of labor, which takes us to the decision of the individual over work versus leisure, the labor-leisure choice. We'll do that at our next lecture. And thank you very much.